All right, today we're going to learn about a couple more properties of exponents. So the first one we're going to learn about is raising a monomial to a power. So to raise a monomial to a power, we're going to use the power rule. So an example would be like this. If I have x raised to a power, but then I have that raised to another power, what you're going to do here is you're going to basically distribute that and you're going to multiply. So I have x to the a times b. So in this case, we're actually multiplying the exponents together as we distribute it. Another example would be if I had multiple bases. So if I have x to the a and y to the b, all raised to the c, just like the distributive property, I'm going to distribute this out. So I end up with x to the a times c and y to the b times c. So in both cases, we're multiplying those exponents. All right, and also, if we have a coefficient as well, we're going to distribute the exponent to the coefficient. So to find the power of a power, we're going to distribute or multiply the exponents. So here are some examples. We're going to simplify each expression using the power rule. So I have y to the fifth, all raised to the second. So I distribute this, and I get y to the 5 times 2, which is y to the 10th. Here, this -3 is on the outside, so it's not going to get anything distributed. So that's just going to drop down. And then I distribute the 3. So a to the 1 times 3 is just a to the 3. And b to the 4 times 3 is b to the 12th. And I'm done. Here, the coefficient is on the inside, so I am going to distribute the 3 to the -2. Now, you have to be a little careful when you're doing negative numbers raised to an exponent, because what this means is I have -2 times -2 times -2. So -2 times -2 will give me a +4, but then I'm multiplying that by a -2, which will give me a -8. Be careful when you plug that in your calculator. You would want to plug it in with parentheses like this, -2 in parentheses to the third. Otherwise, it might mess you up with the negative sign. Then we have a to the first times 3 gives us a to the third, and then b to the second times 3 is b to the 6th. Now I also have this over here, a to the second. So now that I have two a's and I'm multiplying these together, I can use the product rule to simplify. So I keep my coefficient -8. I can add these exponents. 3 plus 2 gives me a to the 5th and b to the 6th. Over here, I'm going to distribute the squared. So 4 squared is 16. 2 times 2 gives me a to the 4th. And then I just have this b to the 3rd. Since a and b are not the same base, I cannot simplify this one any further. All right, so another property of exponents, or another rule, is the negative exponent rule. So essentially, when we're trying to put a expression in simplest form, we can't have any negative exponents. If we read down here, the simplified form of an expression containing exponents must contain only positive exponents. So that's why we need to know how to get rid of negative exponents. So this is how you do it. So if I have x to a negative exponent, what I'm going to do is I'm actually going to move it to the denominator, and so I would put this down below, x to the positive a, it becomes positive, and then since there's nothing, this is nothing on top, I just put a 1 in its place. This also is the same if I have an exponent on the bottom, a negative exponent on the bottom. So if I had, let's say, 1 over y to the -a, to make this positive, I would move it to the top. So I would just have y to the a, moving that to the numerator. So the idea is to get rid of negative exponents, you're going to move them from top to bottom or from bottom to top. So here's some examples. We're going to simplify each expression using the negative exponent rule. However, we're going to use rules of exponents first. So we're going to use product rule, quotient rule, and power rule before we move the negative exponents around, because we may be able to simplify it completely without even using this rule. So in this first one, I see that I'm dividing 2 squared divided by 2 to the -3. Well, first I need to use the quotient rule. The quotient rule means that I'm going to subtract since I have the same base, I can subtract these exponents. So what I have is 2 squared minus negative 3. Well, a minus and negative is actually plus. So what I end up with here is 2 plus 3 gives me 2 to the 5th. And there's no negative exponent, so that's actually my final answer. I got rid of the negative exponent just by using the quotient rule. On example number 2, I have m to the first over m to the negative 4. Once again, I'm going to use my quotient rule and subtract these exponents. So I have m to the first minus negative 4. Once again, I have a minus a negative, which becomes plus. So m to the 1 plus 4 gives me m to the 5th. There's no negatives, so I'm done. All right, over here, I have x to the 4th, y to the 0 over x to the negative 2. Well, y to the 0 just equals 1, so that kind of cancels. And then once again, I'm going to use the quotient rule here, 4 minus negative 2. This minus a negative is a plus, so what I have here is x to the 6th. All right, over here, it looks like I'm going to be using the power rule. So I need to distribute this 2 to each base, and I need to distribute the 4 down here. So what I end up with is 6 squared, which is 36. A to the negative 1 times 2 gives me a to the negative 2, and then b to the 1 times 2 is b squared. On the bottom, I have b to the 2 times 4 is 8. Now, this can be simplified a little bit more because I have b on top and b on bottom. So I'm going to keep my coefficient of 36. I'm going to keep my a to the negative 2. And then I can subtract 2 minus 8. So I get b to the negative 6th. But this is actually not simplest form because I have negative exponents. I have a to the negative 2 and b to the negative 6. Well, what that means is these are currently on top. I have no bottom. It's just kind of like over 1. So to simplify, I have to move these to the bottom. So when I rewrite this, the 36 stays on top because it doesn't have a negative exponent. So I have 36 over a squared and b to the 6th. So when I move those exponents to the denominator, they become positive, which is what I want. And I'm done. So the final rule, and I've already mentioned this a couple of times, but it's this idea that any number raised to the 0 power equals 1. So if I have anything to the 0, it equals 1. And x could be anything. It could be a crazy expression like x squared, y to the 5th, z to the 3rd to the 0. This entire thing is being raised to the 0, so it just equals 1. So that's something else to keep in mind as you're moving forward on skills and homework.